Today we go back to looking at trigonometry, and we see our function here y equal to sine x, and we were going to compare it to y equal to sine x plus 2. Okay, so just like we've seen very recently, y equal to sine x looks like this, and if we add 2 to all of the y values, all of the points are going to move up 2 units. Okay, so let's recall how the sine law works. So according to the sine law, we have a triangle here. We don't have right angles, and the sine law says that these three ratios are all equal. So if we take the sine of angle A and divide it by length A, so this is actually side A, and angles, the sine of this angle divided by the length of this side, which is side B, and the sine of this angle divided by the length of this side. Oops, sorry, I should say B. All of these three ratios are going to be equal. So let's verify that just to see if it's true in this triangle. So the sine of 35.7 divided by 4.7 and sine of 70 So 35 sine of 35.7 divided by 4.7 equals 0.1242. So we're getting numbers very close. The reason they're not perfectly equal to each other is because we have a little bit of a round off error with these decimal numbers. All of these numbers, even though it's to one decimal place, they've been rounded. And so sine of 74.3 divided by 7.7. So let's say we were missing one of the sides, like this side here. What would we do to find that missing side? Well, we could start off with this ratio and equate that to the ratio involving C. So sine C I'm going to write this out with one extra step. And the value we're looking for is small c, which is the length of this side. And so we have an equation. We have 1, 2, 3 numbers and a variable. We're going to solve for this variable. I'm going to multiply both sides by c. And now I'm going to multiply both sides by 4.7. And finally, I'm going to divide both sides by the sine of 35.7. So I leave all of the calculator work to the end. And I get 7.8. It's off by a little bit, and again, that's really due to all these numbers being rounded. Okay. So we want to calculate the cosecant of 45 degrees. In the past, we've done this using Desmos, and we've done it using a calculator. So let's see again how to determine this value without a calculator. So we have this triangle which we've drawn before, and previously we had given lengths to this triangle. We said let's make these two sides equal to 1. Just out of simplicity, we could have picked any number. We could have made them 10 and 10, and then using the Pythagorean theorem, we found that c is equal to root 2. And so the sine of 45 degrees is the opposite side divided by the hypotenuse. And we defined the cosecant. Remember, it was the hypotenuse divided by the opposite. So that would give us root 2 over 1, which is just root 2.